Hello, everyone. Welcome, good afternoon, or good evening, good morning for those in a different time zone. I'm Madhura Maskasky. I'm a co-founder and head of product at Platform Line Systems. And I want to welcome you all to this panel session today. We're going to talk about what lies ahead, everything in the space of Kubernetes and cloud-native data management, all the way from running containers in the 5G context at the edge, to Nodeless Kubernetes, to distributed data services and app-aware storage, and many such interesting topics. I'm joined here today by an esteemed set of panelists. Many of them I personally follow their work, and I'm very excited to be talking to them today. So without delay, let's get started. Let's start with some introductions. So Madhuri, if I can ask you to start first and introduce yourself and tell us a bit about your background.
Sure. Yeah. Thanks so much, Madhura. Hello, everybody. Thanks so much for making time on one of the first few days of KubeCon. My name is Madhuri. I'm the founder CEO of Elotl. We make Nodeless Kubernetes, which enables you to convert any Kubernetes cluster into an agnostic compute Kubernetes cluster. So you can source any kind of compute from any cloud provider for your Kubernetes clusters and spend less time hand curating compute for your clusters. Looking forward to this session and sharing what I've learned about state in the Nodeless world and learning from the other panelists as well. I'll hand it over to Vaibhav next.
Thanks, Madhuri. Hi, everyone. My name is Vaibhav Kamra. I'm the CTO here at Kasten by Veeam. At Kasten, we have been working on data management for Kubernetes applications. So think backup recovery, application mobility since 2017. So really excited to talk about that stuff today. But I've been using Kubernetes even before that. So I started using Kubernetes pre-1.0 back in 2015. So I've been in this community for a long time and excited to talk about this.
Great. Sam, would you like to go next?
Sure. I'm Sam Ramji. I've been in the industry for a little while, 26 years now. I was at Google for a couple of years, 2016 to 2018, and I was vice president of product management responsible for Kubernetes as well as DevOps. And since then, I've gotten to use it at scale at Autodesk, and currently I'm chief strategy officer at DataStax. And what we're focused on is Cassandra, which is the most available scalable database. Bringing that to Kubernetes in a way that's totally native and that works really well in the ecosystem of other storage and data technologies like Kasten and a range of other concerns. So as we make data on Kubernetes a real thing, I think it's going to take all of us working together in open source and open standards to make it work.
Fantastic. Very excited. Sam, thank you. And Suresh?
Yeah. Hello, everyone. My name is Suresh Somasundaram. I'm based out of Denver in Colorado. I head up the platform engineering function here at Mavenir Systems, the industry's only end-to-end cloud-native 5G software services and product company based out of Richardson, Texas. And my foray here at Mavenir is to bring the telco touch to the cloud and the cloud touch to the telco and make it a seamless two-way traffic across the board.
Fantastic. Suresh, great to have you. So thank you, folks. Thanks for those introductions. Like I said, a really great panel here. So let's kick off, Madhuri. I'd like to kick off with you. When I first heard about what Elotl is doing with Nodeless Kubernetes, I thought it is very exciting. We'd done something similar with a project Fission, an open source project for serverless on Kubernetes. And so I wanted to ask you, can you start by telling us a bit about what Nodeless Kubernetes really is? And then how do you see that trend evolving into possibly becoming mainstream from your perspective? And also tell us about the KIP project.
Yeah, sure. Yeah, thanks, Madhura. So Nodeless Kubernetes was fundamentally born out of my experience helping large enterprise customers in my previous startup, which was Cluster HQ, where the project Flocker helped run stateful apps inside containers. So we were helping large enterprises like Salesforce, United Healthcare, take their monolithic apps running in virtual machines on on-premise VMware data centers, and they were trying to shrink wrap them as containers and run them on the cloud providers. And we saw that they were taking the practices of compute management on on-premise data centers, they were doing a lift and shift of the same practices to public cloud, where you think about, hey, this year I'm going to run 100 applications. I need X amount of CPU, Y amount of memory for my 100 apps. So let me go and procure these server blades and stick them in my data center. And the same compute management practices were being carried over to public cloud, which is quite different from on-premise data center, because irrespective of whether they were using 50% or 70% of the provisioned capacity on public cloud, they were paying for 100% of the provisioned capacity. Mm-hmm. And they would hit all these budgeting limits, and then all of a sudden they were wondering, hey, we are spending so much month on month on public cloud compute. Are we really using all of these compute resources that we are provisioning for? And by the way, there are on-demand instances, there's spot instances, there's Fargate launch types. How do I stitch my cluster together? What should my node pools be composed of, etc.? So that made us take a step back and think about, hey, how would Kubernetes be developed today if we know that it would primarily be deployed to public cloud with a completely different characteristics of compute from on-premise server blades? And Nodeless Kubernetes was born as a result. So basically, the cloud providers give you very large capacity of compute resources at an API call. Each compute resource is available at various price points and various sizes and various resource footprints. So Nodeless Kubernetes fundamentally presents a virtual worker node to your Kubernetes control plane, and you're not pre-provisioning the worker node. So as the control plane schedules apps or pods onto this virtual worker node, the virtual worker node will spin up just-in-time right-sized compute for the pod and dispatches the pod over to the compute node. Once the pod terminates, the underlying compute automatically terminates. So instead of thinking about a large set of bins of compute resources that you're stuffing pods onto, you're packing the bin balls of different sizes. We have a deconstructed cluster, which is more cloud native, and you're preventing wasted spend. There is much more operational simplicity because you don't have to hand curate your node pools and compute resources as part of your node pools. And also you have a stronger multi-tenant security because each pod gets its own bespoke compute launch type. So that was how KIP was born. So KIP is a primary project that is based on Virtual Kubelet, which is another CNCF project that is also aligning it with the Nodeless state of mind, basically. The reason we open sourced KIP was it's to be in the spirit of the Kubernetes ecosystem. Is we want to have an open core kind of model, and the product needs to be available to people that actually want to try to use it, because there is no point in having a product if it is not usable by people who are facing the problem. So if there is enough of a market share, the business will follow naturally. So that's the reason we open sourced KIP, and we've had great amount of inbound traction, because there is, as cloud adoption of Kubernetes increases, the idea of Nodeless is a lot more clean slate Kubernetes approach for adopting Kubernetes on public cloud. Does that answer the question, Madhura?
Yeah, absolutely. No, I think that is fantastic. And I think you kind of touched on that one key principle, which is especially in this ecosystem that we live in, if you have a very interesting, unique idea, and if you want to get even broader validation for that, open sourcing it as a project is probably the most effective way of doing it. And that kind of, leads to my next question, Sam. I've been listening to some of your podcasts, and you also touched on some similar points where you've mentioned that since you joined DataStax, you've kind of brought in a focus of aligning more towards open source. Can you talk to us a little bit about that?
Yeah, open source is kind of this amazing environment where everyone is playing a positive sum game, and literally everyone who plays the game makes the game better for everyone else, which is kind of different from how the software industry grew up in the 80s and 90s, which was kind of zero sum. There's only so much market share. There's only so much money. There's only so much good software and good ideas to go around. So we've graduated from that, I think, as an industry. And that's what has made phenomena like Docker and then Kubernetes, all built on top of Linux, force for, a great up-leveling of our ability to manage all the physical infrastructure that we care about so much. So one of the things that you always look at is, how healthy is the business? Well, as Madhuri said, how fast is the open source growing?
Mhm.
With the free open source with no commercial support, that represents really the market opportunity for everybody in the ecosystem to say, well, what parts of that are still unsolved? What parts of that can I offer some kind of additional commercial support for, whether that's some algorithmic support that's encased in software, or whether that's kind of expert services that are done by people to help you succeed. So with DataStax, we found that Cassandra has grown a very strong reputation of being spectacularly scalable and available, right? Apple uses Cassandra as the basis of iCloud. So about 200,000 plus nodes of Cassandra, extremely well tested. As they say at Apple, if Cassandra didn't run, the world's iDevices would be dark. And so that's kind of maybe a lighthouse of an enormous environment, but we also see a lot of Cassandra in smaller environments, 3-node clusters, 9-node clusters, 50, 100. The thing that has attracted everybody's attention in the Cassandra community is Kubernetes. Kubernetes is the single fastest growing skill among the tens of thousands of Cassandra experts worldwide. So as we look at what is drawing all that in, well, stateful workloads are really important to figure out how you can get the elasticity that you get from stateless workloads. So there have been many different operators created. If you're familiar with the CoreOS operator pattern that's now part of Red Hat, many of us have taken the operator pattern as a way to run stateful workloads on top of Kubernetes. And we're making more and more progress on that, I think, every day. What we've done at DataStax is to marry open source Kubernetes hosted by Google or Amazon or Microsoft, right, in GKE, EKS, or AKS. And by bringing those two things together, we have learned so much about what a distributed database, which is typically designed as a monolith, needs to do to open up and participate in the Kubernetes control plane. So with boring the audience, I'll just say that there's a lot more than just the database running as a cluster on a set of nodes. There's a lot about being able to give up control back to the Kubernetes control plane to participate in rolling restarts, to make sure that all of your information is going into Prometheus and Grafana, so that it's not an island running your stateful workloads in a totally different way than all of your stateless workloads, because what we're entering into is a unified control plane. It'll make the SRE's life easier, and it lets all of us participate in this application-aware infrastructure, which I believe is the defining movement for the next decade of computation, whether you're doing it on your device, in the cloud, or all the way to the network edge in a 5G environment.
Very interesting. Sam, thanks for walking us through that. We've ourselves been personally or at Platform9 users of Cassandra, and being able to run it on Kubernetes in a way that you're talking about, I can see that being useful to, I think, millions of users. So kind of on that topic of app-aware storage or data or state management, Vaibhav, I want to pull you in here. That's been a topic kind of near and dear to your heart, I guess. And at Kasten, it's one of those core value propositions that you and your team focus on. Can you talk a little bit, especially because we want to talk about what lies ahead and some of the trends? What are your thoughts in terms of future trends in the app-aware storage or data management space?
Yeah, no, thanks, Madhura. I think so. That's a good question. I mean, it's something we spend a lot of time thinking about, and I think what's really interesting to talk about is what has happened and is what is happening when it comes to application development. So what we're seeing right now is, or what we used to see is that infrastructure really used to define how applications were built. So I used to work, for example, at SQL Server, and we would classify customers as SQL shops or Oracle shops or MySQL shops. And what that really meant was that if you went there, you would find a single data service, and kind of all applications would kind of be built the same way. But what's happening now, what Kubernetes and Cloud Native, the ecosystem has done a really good job of enabling, is that developers who are building these applications can really pick and choose the right tool. The infrastructure will enable them to deploy whatever they want. So you could have applications that are running Cassandra or Postgres or file services or object store or cloud services, a variety of different things. Right? So the makeup of the application is what's defining how the infrastructure is laid out. And so what's happened with this change in how applications are being built and deployed is that infrastructure has kind of had to adapt, right? So Sam talked about it being more than just deploying an application. It is actually giving all the information to the underlying infrastructure around what should my topology look like, what are my fault domains, what do I care about, what are the different kind of APIs I need. And so what we're seeing in terms of trends are we're seeing new APIs show up, really good abstractions, things like CSI for storage. One that just went in, for example, is an API around object storage. We're seeing almost all data services move to this operator model, which is really powerful because it allows application developers to just say, I want an instance of a data service and I want it configured this way. So all of this is happening with the application. And when you start looking at it from a storage or even backup and DR point of view, the only way to kind of get this right is to be application aware. It's no longer enough just to say, I'm going to back up volumes or snapshot volumes for an application and it'll come up, or just capture the VMs. You really need to go understand, how is this application built? What are the different data services it's using? What does it need? What are its other dependencies? And so I think that's something really interesting that's happening. And you see it across the board when it comes to networking, service mesh, storage, data protection. Application awareness is really what's key there.
That's fantastic. It's really interesting, just within the panel, we kind of get to see two sides of the picture, right? Sam, you're on the one end where you're trying to break this monolithic app, almost deconstruct it to make it more native and more open. And then that's a trend that Vaibhav, your teams and similar companies are taking up and saying, now that these monolithic apps are breaking up, we have to, do our part of the game. And so we have to be able to give them more intelligent storage. And I think ultimately consumers are just going to benefit in a really big way through this kind of trend, with both vendors and providers kind of aligning together. So that's very interesting and definitely a trend to watch for. Something, Suresh, I want to pull you in because you're kind of a very interesting consumer of Kubernetes and even data from that perspective, because of what Mavenir does, you focus on problems of deploying containerized workloads at the edge, right? At radio cell towers, where you're probably very limited in terms of resources. So one thing I've been always curious about and wanted to ask you, specifically from state management perspective, what are some challenges that some of these workloads experience when you have to deploy them at these radio cell towers, where you probably have a single server, maybe at the most 3 to deploy them on?
Sure. When we look at, the implementation of radio type workloads, like the new radio type workloads at the far edge sites, like just you called out, there is, plenty of the radio cell sites out there. We got to distribute, manage, and so on, and operate seamlessly. And then, in each of those cell sites, the resources are very less, be it compute, storage, network, and, things like that. And, on top of it, the performance requirements of those workloads are extremely high. They are latency sensitive and performance intensive type workloads. So you got to give, very high degree of performance and throughput on very lean infrastructure. And, and so when 5G as a technology paradigm evolved, we started sort of breaking down the monolith into a sort of microservice styled architecture. We broke it down into DU and CU. The DU, the distribution unit, is the one that resides on the far edge side, and the CU components resides a little bit upstream on the edge data centers, or the local data centers, as the operators would call it. Now, as we started deconstructing this whole, the components, so to say, we took some cues from the web scale world in terms of how some stateful transactions can be moved to a sort of like pseudo stateless transaction, if you will, in terms of like, providing a backend database driven support, kind of like, how, Cassandra's evolved over the years and things like that. And then in some cases, we've also looked at analyzing the workloads. There are generally 3 types of workloads as we look at it in a web scale world or in a telco world. One is like an always on workload, like the radio type workloads that we see. Then the second one is like the web scale transaction, API, service-centric type workloads, which you will see more on the back end with 5 core type functions. And then there is a third thing, which is more like the batch processing type transactions, which you will see more in the fintech type areas and so on. Now, fortunately or otherwise, the radio type workloads falls heavily in the always on type workload. This is all like, streaming data traffic type scenarios where you cannot even have, a storage, so to say. So the onus of the pressure kind of like a little bit falls on the upstream applications, the radio components. For example, within our radio components, we look for cues like KPIs and metrics about, and I keep discussing this with our teams internally, which is like, one is the ability to anticipate. The other one is over time is the ability to anticipate correctly. And then we turn it around in terms of, in terms of the resolution and so on. In a radio type scenario, the requirements are so stringent that you need to take a sub-second moment to identify the anomaly. And you usually have a time window, if at all we call it as a time, of 1 to 2 seconds to turn around and recover the scenario. So, in such cases, it becomes very, very challenging and complex. But this is not a problem that's kind of like introduced in a cloud native environment. If you look at it, if you take a step back and look at the bigger picture, this kind of exists even in today's 4G or even in the pre-4G era in the legacy world. So applications have been hardened over time to look at these anomalies and KPIs and metrics and how they tend to go about it. The good thing with cloud native with a microservice architecture is we've tried to bring the scope of failure to a targeted microservice or an individual component and reduce the blast radius of the impact per se.
I see. Interesting. Very interesting. So especially kind of going back to that point of always on workloads, but with limited resources, I'm guessing there's probably all of these optimizations around all of the main data lives at the core or some of your mid data centers, but then some data is kind of brought in as a cache of things that are just absolutely needed for the radio cell towers. Is that right, Suresh?
Yep.
That's great. Yeah, very interesting. So, one of the things, Suresh, also wanted to ask you, since you're again at the forefront of the 5G, evolution and a lot of innovation happening there. An interesting thing that's happening in the 5G space is it seems like almost that the 3GPP standard, and we've spoken about this, has kind of put a loose requirement around building services in a microservices-led pattern, and that's kind of leading to a lot of telco or 5G vendors adopting containers in a pretty big way, right? Traditionally, you don't quite see that kind of momentum in a telco industry, but it's very interesting to kind of see that pattern. Can you talk a little bit about how you see that evolving as 5G gets rolled out, and getting more containers deployed at the edge and etc.?
Absolutely. The story is kind of very similar to what Sam was calling out earlier about, how the software evolution has been happening and how Madhuri has been talking about the data center evolution piece and so on, right? So we've kind of like, seen a very similar evolution, so to say, in the telco world, in the wireless operator world. In terms of, say, for example, we're going away from a monolith to a microservicized infrastructure or an architecture, so to say. And if a simple rough back of the envelope calculation for a large telco operator having, say for example, like a Vodafone who has like about 26, who plans to have about 2,600 radio sites, on open RAN architecture basis. And now you have the core microservices running on the 5G core side. A rough back of the envelope calculation would give you about 10,000 to 12,000 software deployments at scale based on the number of changes we want to orchestrate, new features we wanted to introduce, the maintenance patterns, and the number of target sites where you want to deploy, optimize, scale, expand, operate, and things like that. So in such a scenario, it becomes automation is a given, and with Kubernetes we are able to kind of like provide that at scale. And then in a managed Kubernetes type environment, you obviously create a marketplace type scenario where you can onboard your workloads and then distribute your workloads to different target cell sites, and the Kubernetes will take care of the scaling, the agility aspects of it. So it makes it a little bit easier. So it makes good sense. And we've kind of seen a lot of adoption of a containerized implementation across the board, be it greenfield implementations like the one that's been happening in Japan, led by the premier, wireless operator out there, Rakuten, or for that matter, even the 4G, 5G type scenario, the combo scenarios as we call it. We've kind of seen that kind of containerized adoption happening. In some workloads, especially what we call as the non-standalone type workloads, where we have some parts of old legacy type implementations and some on the newer 5G type implementation, we've been looking at scenarios. How do we try to create a KubeVirt type environment where we can run everything on a single level playing field? So we've, so that's one thing. The other aspect is obviously the evolution of 5G has also opened the eyes for looking at open source ecosystem very closely. There's a greater degree of collaboration that's happening more now than before with CNCF, with the Linux Foundation. In fact, at Mavenir, we take pride in partnering with the XGBella Foundation, where we are trying to create a telco PaaS layer, and we are offering our code and the seed code to help create that affinity or the closeness between a cloud and a telco implementation, so to say.
Very cool, very cool. Suresh, we've seen some of these developments closely, so it's always interesting to know the next time one of us picks up our phone, the call is gonna get routed to a cell tower that's actually gonna be running as part of a Kubernetes cluster. So really, lots of interesting innovation there. Thanks for sharing that. I wanted to bring kind of the panelists in. One of the topics I'd love to hear all of your thoughts on is really the trends in the context of Kubernetes and data management, right, that you are all kind of personally excited about. Starting with Sam, we were chatting a little bit yesterday, and I've also been listening to some of your talks, and you do talk about distributed data services and the role of AI or ML could play in, for example, making databases more dynamically reactive, or letting users make better use of this massive amounts of data that they're going to accumulate. Is that a trend that you think is here for stay from a future perspective? Can you talk to us about that?
Yeah, I think the big arc is that this decade will see IT becoming more industrial, right? Sort of industrial operations, large-scale industrial management, and Kubernetes is enabling this transition from kind of artisanal stage of IT to an industrial stage. And as the famous quote goes, the future is already here. It's just unevenly distributed. Spending a couple of years at Google, one of the things that I realized was it wasn't just extraordinary technology that we had with Borg and with Megastore and Spanner. It was how we made that available to the business units, right? We had an industrial model internally called the resource economy, and it's so frequently described inside Google, they just call it the RE. So it gives you the opportunity to pay for the things that you need to use, so the different parts of the business and net new businesses within Google, you could start a brand new data business, figure out how you're going to fund it, how are you going to get the compute and the data processing resources you needed to offer some new service. Like if you think about Google Photos, right, that is paid for out of the resource economy. It's also a great example of an AI technology, right? It's an AI product that will help you understand, right, this incredible diversity of photos that you have. So that's something that Google had in the last decade. So as we look at the next decade, a lot of those affordances are showing up. Borg becomes Kubernetes. But what about the data part? How do you get Megastore and Spanner on premises, cross clouds, right? That's some of what we end up seeing a lot at DataStax around Cassandra on Kubernetes. The unit economics end up being where the whole thing lives or dies, because if you say, I can afford $60 million a year to pay AWS for my cloud infrastructure, and you see a rising volume of data requests from your AI workloads, and your AI workloads are the ones that are satisfying your customers, your consumers, your partners the most, because they're helping them get their job done. Think about autocomplete. Autocomplete's a great example of AI in your browser. Every time you type a query, remember the last time you had to type out a whole query? Yeah, neither do I, right? As you type, it's interacting with the back end and telling you character by character, here are the 3, 4, 5 most likely things that you really want to be searching for, and that adds value. If you introduced a search tool today that didn't have autocomplete, people would consider it broken. So you start to see that the rising tide of AI creeping up behind our popular awareness, it's just better features, just augments our intelligence, has a huge impact in how many accesses of the data layer come through. So if you can't constantly drive down the unit economics of each access against the data layer so that you can do a little extra processing, then you're going to end up in a world where most of your company's budget is going to end up going to compute and data. And that's a little bit weird. You have to target a deflationary environment. So as we think about the AI future, we can say pretty confidently in the next 5 years, we're going to see 10x as much data traffic just to serve AIs than we do see global traffic today. So you should take a strategic planning assumption for what comes next and say 5 years from now, my per unit cost of accessing my data layer has got to go down by a factor of 10. And then you can advance that out to the next decade and have that same perspective. I think that's the most helpful guidance I can offer the audience as you look at what is over the horizon. You have to take an economics approach to think about what's the new basis that you have to design all of your industrial IT around as you figure out how to grapple with the needs of the future.
Very interesting. Yeah, because I guess the need to make your apps, regardless of what industry you are in, the need to use more AI to make your apps more responsive, giving better experience is only going to grow, right? Because if you're not doing it, your competitor is definitely doing it. So there's going to be that pressure. And so planning for it in advance is definitely a very important and good tip to keep in mind. Vaibhav, what are your thoughts in the context of data management, some of the trends that you and your team are most interested about?
Yeah, I think so. The most exciting thing that's happening for us is really how the entire community is really enabling these developers to build the kind of applications we just talked about, right? So we often talk about if we wish we had access to Kubernetes and these cloud native kind of ecosystem projects much earlier in our careers. Imagine the things we could have done. And so it's really enabling these amazing applications. What's happening with that is, it's just a matter of time where you're seeing Kubernetes deployed all across, right? Different verticals. Suresh just talked about cell towers and 5G, and we're just seeing it all across the planet. There's an increased kind of requirement around all the operational, the day two kind of use cases. And so that's what keeps us up at night. That's what we spend a lot of time thinking about. And the other initiative that's happening, it's more of a DevOps initiative, it's called Shift Left, which is a lot of these thoughts around what am I going to do for security? What am I going to do for backup and recovery? How does my migration work to a different cluster, DR? This is all happening not at the end when I'm going into production. This is happening right up front when an application is getting built, when it's getting deployed, earlier in test dev environments. And so I think these trends are really exciting because it means that from an operations point of view, the kind of products you build have to be very different than what we used to build, right? You have to think about automation and GitOps and infrastructure as code and having clean APIs, self-service. So these are the kind of things that are interesting to us.
Very interesting. Yeah, absolutely, and well said. Madhuri, let me go to you. You kind of play in this really interesting world of Nodeless Kubernetes, and one of the things you probably get asked often is, what does state management mean in the world of Nodeless Kubernetes? Something I want to learn about as well. So can you tell us a little bit?
Sure, yeah. So this kind of ties into the whole shift from monolithic apps to microservices that Vaibhav and Sam and Suresh have spoken about so far, which is, and from my own personal experience, helping the early adopters of containers on public cloud providers, what we've seen is that the way people are structuring their microservices applications, it's not, their apps are no longer pets, but they are supposed to be treated like cattle. So if one instance of the app goes down, you should be able to transition over the workload to another instance of the app. So the traditional sense of every instance of your application needs to carry this heavyweight state along with itself is no longer true when you take the shift from data center deployments to microservice Kubernetes deployments. So having said that, what we have seen is that people are either have a heavyweight stateful application that is so important that they don't want to be responsible for deploying it and maintaining it themselves. They want it to be deployed on a managed service like DataStax or another managed service for DR like Kasten, etc. Or the other option is they have lightweight state components like logs and things like, config files and stuff like that, which are kind of stateful, but not like the heavyweight database kind of state. And they don't want to lose those for triage purposes when the app gets shut down. So in the Nodeless world, that is the reason why the first support for state has been through a distributed network file system like EFS. Fargate now supports running state deploying state on EFS. So normally, if you think of your on-premise data center deployments, you think about, hey, if I can outsource my state to EFS. What about the performance? What about the SLAs? But when you think about the cloud-native microservice deployment fashion, if your state was so important, you could have used a managed provider, and you're not doing it by yourself. And for the lightweight stateful components, a network file system is good enough. So in the Nodeless world, the first year of support for state that is available right now is the distributed file systems. And there are plans for supporting EFS kind of state as well in future, but it is not as important in the cloud native microservice world of deployment. Does that make sense?
It does. And what you're saying is, kind of for that lightweight state for config files and et cetera, use maybe a distributed file system. But for the most part, for your important data, you should really be looking at consuming a managed service, a completely, managed data store. If you're not doing that, you're doing something wrong. And that's probably a kind of trend on a, kind of vendor side, Sam and Vaibhav, you're probably also seeing where there's a need possibly even to provide offerings of what you're giving as a SaaS service, so one could just consume it as an endpoint without having to worry about where it's deployed or et cetera. Is that fair to say?
Yeah, that's been the big change in our business this year, is that we were, sort of very staunchly focused on Cassandra and open source and on premises, including when your premise is your AWS infrastructure, right? Because it feels like, people talk about it as public cloud, but it feels like your data center. If you were used to logging into Equinix, right, logging into your AWS environment isn't that different. So there's a lot of installed deployed software there that doesn't feel a lot different from how it used to. But there was so much demand that in May, we completed about 18 months of engineering work to launch a database as a service called Astra, which is Cassandra on Kubernetes. Took us good 18 months, I think, to get it on our first cloud, a few months to get it on our second. Now we have all three North American clouds covered. And there's tremendous demand for two things. One, just operational simplicity. People don't want to, in 2020, deal with configuring their database. Smart defaults are important, but a lot of it should just get dealt with. The elasticity that you're used to in your stateless environment, nobody gets it out of their database. There's way too many things that you have to do, knobs and dials that you have to tweak, and buttons to push, and that becomes really not the best use of scarce time of an SRE or a developer. So that's driving demand for DBaaS, and you can see that. We've seen that in our business. You can see it with Mongo and MongoDB Atlas. You can see it with Dynamo. You can see it with Google Cloud Data Store. A range of different higher level data stores, unlike a file server, right? Unlike EFS, which again, if your data is well represented as a file, you use that. But so much application data is a document, or it's a key space, right? As a columnar store, and you want it to just work because you want your application tone to be present to the user. It'd be nice to have everything just kind of manage itself in the background. So that's the first big reason. The second big reason is you would actually like it to be somebody else's fault if there's a problem. We don't talk about this a lot as vendors, but I've moved back and forth between being the customer and the vendor in my career. And there's a really important moment where something's going to go wrong eventually anyway. And it's actually a lot better for everybody at the company if it's the vendor's fault, because you retain the institutional knowledge. Nobody gets fired. You yell at the vendor. They authentically say that they're very sorry and they fix the problem, but you can figure out what those relationships are while retaining your morale and your institutional knowledge within the corporation.
Very interesting. Yeah, I didn't notice that Astra announcement from you guys, and yes, that's kind of like that trend that almost every vendor seems to be following, especially in the storage and data management space. Because like you said, right, I think the vendor would rather be that single throat that all of their customers can choke and take that responsibility and in turn deliver the best possible experience, because that makes lives easier for both of them. Vaibhav, is that a trend you see in the DR backup management space as well?
I think I'll be a little controversial here, and I'll say that there's definitely a need and a requirement for managed services, and we see that across the board. But I think being able to kind of deploy and manage these data services, these data stacks, pun intended, in your own environment definitely exists, right? Whether it be for cost, compliance, just the innovation that sometimes, or even performance that you need. So we're definitely seeing a lot of demand there. And I think what's really exciting is that the concerns that we talked about in terms of operational and reliability, they're definitely there. But because of that, we're seeing so much innovation in the operator space, in the kind of SRE as code innovation that's happening. And so I think data services are evolving really a lot. There's definitely a need and a requirement for kind of both types of environments. The challenge we have as folks who go ahead and support these environments is, how do you support applications that are going to do both, right? Maybe I'm going to use RDS or Astra for a certain data service, but I'm going to use an embedded database for, I don't know, just my catalog metadata. And so we see those kind of applications a lot as well. So I think it's always going to be a mixed bag. And that's where application awareness comes in. You really need to understand what they're doing, how they're doing, and make sure you have a story for everything.
Got it. And kind of also making your apps easier to manage, regardless of whether they're hosted as a service or the customer is hosting it themselves, is always going to go a long way. And making them Kubernetes native is a big part of that. Suresh, from a consumer perspective, I guess, if you can speak on behalf of the telco vertical, what trends do you see in terms of adopting more managed services versus wanting to run everything, kind of on premise and having it under control, etc.?
So we're seeing an interesting bit of a change, or even repositioning of where we are today. Managed services continues to be there, but how we do is going through a huge change. For example, customers are increasingly becoming capex savvy and very, very opex sensitive too, on an annual operational basis. So they're looking at or pushing us in a good way to find creative ways of trying to ease the cost of deployment and operations and maintenance and things like that. So in terms of, say, for example, how we deploy software today in a radio network or in a core network in one data center or in one private cloud type environment, is now we're now going to multiple sites of deployments. So orchestrating the change without us creating any impact, without us creating any incident to the end user is very critical. And we've used ways like CD, the continuous delivery. On the CI/CD piece, we stress more on CD more than CI, so to say, because we want to make sure that any change that we propagate, makes it to the last site seamlessly, in a very clean fashion. So, and again, managed services tries to bring all of this together in a very nice cohesive way, because we still want to track against all these, high performing operational metrics and, availability times and things like that. So it's a sum of parts proposition there.
Interesting. Okay, so you see that adoption of managed services, especially for that simplicity and some of the cost savings that it can bring.
managed services with automation and with all
Mm.
data and insights and
Mhm.
automated decision making, self-learning using AI, ML techniques, and all of that stuff. So
That's
it's
right.
not just plain vanilla managed services.
But also with transparency, right? I think, I like Vaibhav's point, which is, I think, candid and accurate, which is you trust managed services up to a point, but you want to know what's going on inside it, because what if you decide that you need to fire your managed services provider, right? What if you need to change your deployment environment? What if you need to go to a cloud that your managed service provider doesn't support? You don't want to be stuck based on their choices. So this is kind of part of what I think is coming up now as a future pattern. So for those of us looking over the horizon, or even present day, sort of emerging trends, the ability to have an open source technology as a service rendering of that open source technology, and then landing it on a hyperscale cloud, kind of gives you a détente where you aren't harmed by changing. You could copy your stuff to a new cloud, you could change managed providers, but the whole time you've got that open source component that you can trust, even if you stop paying for it. And I think that's what we've all been trying to figure out, is where does open source meet the cloud, and how do you continue to get the freedoms you're looking for? So managed services, but with transparency and trust through an open source core.
Yeah, no, absolutely. I think that probably is one of the most important, valuable aspects of staying true to the open source ecosystem, I guess, but still delivering best of breed experience, not compromising on the experience because the software might be built through an open source community. So we certainly at Platform 9 believe a lot in that trend, and I think it's definitely here to stay. On a related topic, I wanted to get the panel's view on something that we were discussing just a little bit yesterday, which is, Sam, again, you made an interesting comment, which is, in the context of data portability, what is a container for storage? We have, this nice abstraction of containers in the compute context, which is now given us a lot of portability benefits, but storage hasn't quite reached that point yet. And so you tend to see a lot of issues around being able to migrate data from one endpoint to the other. One question I want to start by asking the panel, it's something that I've definitely wondered about, which is, and maybe a little controversial, but, is how important it is for enterprises today for deployed apps to be able to have the choice of moving them around across different clouds on a dynamic basis. In other words, once your app is deployed, isn't it true that a lot of enterprise apps would just want to stay at whatever cloud that it's deployed on, but you rather want the ability to deploy new instances in additional clouds, say? So how much is that part of the portability really critical, that you should be able to take one app and all state and move it around to another cloud and then move it to another, etc.? Vaibhav, why don't we start with you? Maybe relevant to what you guys do.
Yeah, I think so. So when you look at Kubernetes and Docker, actually, what we have enabled here is, as you described, deployment portability. You can build your application and you can deploy it pretty much anywhere you want, whether it be on a laptop or a cloud environment or something on-prem.
Mm-hmm.
But when it comes to data, and actually I would say not just data, but state, because Madhuri mentioned this, we often think about data and that's it. There's also a lot of state in the application that is also needed, that is also sticky. Think about things like certificates, maybe you need some log messages, config files, all of that stuff. So when it comes to all of this on a deployed application, that portability isn't really there native in the Kubernetes platform today.
Mm-hmm.
I think it is really important as a use case. It's a little nuanced. You mentioned dynamic. I don't think, at least customers that I've talked to are looking to, move around applications, constantly. So I have it in one cloud today, I'm going to move it around somewhere else and then move it back. That's not what I've heard that they're looking for, but what they are looking for is the choice, the ability to be able to, for example, for business reasons, move from one environment to the other, whether it be responding to competitive threats or COVID. COVID actually caused a lot of people to move and shut down their data centers and move into the cloud, just because everybody's remote is just easier to manage sometimes. So I think the portability is definitely a requirement that's coming there, and that's where, when we think about, again, the application, you've got to take this full view. You've got to worry about where is all the data. It could be in a managed data service. It could be in a storage provider. It could be stuck in config files in Kubernetes. And you're going to make sure you capture all of this and think about how you're going to move this around to enable that use case.
I see. Interesting. So a lot of burden still on the end users, and it's because the data is kind of spread across various different services and endpoints, right? So
well, that's exactly actually the problem we're trying to solve here at Kasten, which is, you know, to solve that problem, because it really is a problem and a use case that needs to be solved.
Mm-hmm. I see. So is the approach you guys are taking kind of no matter where your data is, for the most part, we're going to figure out a way to have you covered from that portability perspective?
It really is. It comes back to app awareness. For us, when we say app awareness, it means, first off, don't limit developers. Let them do what they want to do. Let them pick a managed service. Let them pick something that they deploy themselves. Let them do whatever they want to do. But then ensure that for the operation teams, you can enable the use cases they want, portability, backup, DR, and discover where everything is and capture that and have a mechanism for that.
I see. Okay. So discovering and reporting, just so that you have a broader perspective, goes a long ways. Makes sense. Madhuri, your thoughts?
Sure. Yeah, this is actually very close to the space in which we are playing in. So one of the things that I've noticed in the 20 years of playing in infrastructure space is that Kubernetes has become so popular because it's kind of become the Linux of platforms. So it's become the commodity for how a platform is defined, so that any enterprise doesn't have to spend large armies of DevOps engineers building bespoke custom stacks for their infrastructure, and they can build applications to run on a Kubernetes cluster. Now that we've standardized on Kubernetes as a platform, being super sticky to a cloud provider, there isn't any business value out of that for an enterprise consumer. If your business is building an ML for recognizing whether strawberry is grade A or grade B, why should you hire a team of 20 AWS experts that know how to stitch together node pools and configure your cluster auto-scaling knobs? That's completely irrelevant to your business value proposition. Because Kubernetes has standardized the platform, Nodeless is trying to actually commoditize public cloud compute so that you don't have to worry about where my compute is coming from for my ML application. All that you need is, I need 1 vCPU, 1 gig of RAM for my pod. Deploy it wherever I can get that compute. So you might have some policies that might say, get me the lowest cost compute. These are my budgeting policies. And from a user of a platform point of view, that's all that you care about. You don't need to know what the node pools are. How do you scale up? How do you scale down? You don't need to build all of that expertise in-house. So we do think that as Kubernetes has commoditized platform across various cloud providers, across various verticals, kind of decoupling yourself from being sticky to the kinds of compute that each cloud provider offers and the special kind of scaffolding that each cloud provider offers, it actually slows down your adoption of Kubernetes as a platform. And once you can break away from treating compute as pet and you can treat it as cattle, then you can easily shift between cloud providers based on your business SLAs and your policies and your budgets and the sizes of your ops teams, etc. And this kind of ties into Vaibhav's point about like what is state in this context, right? So state is always following compute. So again, having the state lifecycle be decoupled from the compute lifecycle is additional overhead on the ops team. So if compute is following the application lifecycle, then state follows the compute lifecycle. That's a lot more agile way of consuming Kubernetes that is in a cloud agnostic fashion, and that will let you focus on your core business value proposition instead of being distracted by all these things that are not helping you with your business. Does that make sense?
Yeah, no, it makes sense. I think that's definitely a good perspective. I think one of the things I want to learn, Sam, is from perspective of you and DataStax, because you guys are maintainers of a data store that is just sticky by nature, right? There's a ton of data that you ingest, and so what kind of challenges you see or what questions customers ask you from a portability perspective? Is that something that they worry about, care for? And what are you guys thinking from a future trend perspective?
Absolutely. And to contrast with Madhuri's comments, which I think were spot on, there's a piece that is pretty complex about having your state follow your statelessness, which is state's heavy.
Mm.
It's really, really heavy, right? A small database is a few gigabytes. A big database is a few petabytes.
Mm-hmm.
So you end up with physics problems around the movement of data. Furthermore, when you're dealing with databases, it is not simply a matter of copying the bits, because a database is an indexing structure. So as you land those bits on a new environment, loading that database, moving the data, means that it all has to go through computation now, so that the new bits have been written to a place where they're discoverable, alterable, right? All of those different components. So it can take you rather a long time to move the state. So when you think about app-aware infrastructure, right, and data that can follow that around, you have a speed of light limit. You have a very small amount of information that has to be moved in the app, and you have a lot of information that has to be moved in the data. So what we're seeing is a lot of demand for intelligent replication. How can you have just enough data to satisfy the users who are going to use the app at that time in that place, right? Because everything is geospatial, right, and temporal. So you've got those dimensions in everything, plus you have the data itself. How can we use that to figure out how to intelligently move data around so you're not paying replication costs for your entire data corpus for every application to every data center in your cloud environment on the planet? Because again, you will pretty quickly destroy your unit economics, and then your entire company budget will go into compute and storage, and that'll be crazy. So we see a lot of demand for portability, and I would distinguish portability, as Vaibhav did, from dynamic workloads. We see demand for both, but the lion's share is portability. And here's the tension. Change is the enemy of predictability, right? So your SREs want to deliver availability correctly. They want to manage change. You've got CI/CD. You need to have a lot of updates, but if you can have as few dimensions of change as possible, you're in better shape. So you'd like to keep all that workload on one cloud or one environment. But here's the problem. Lock-in is the enemy of discounts.
Yeah.
If you can't get off your cloud provider, they are not going to give you a substantial discount. And I have personal experience with this as a customer. Right. So I would say in a nutshell, portability, the way that customers describe it, is something that will allow me to choose to move, even if it's going to be a lot of effort to move, but it makes it possible. I can schedule it. It's going to be weeks or months to do that. I will say that while for most workloads, dynamism isn't needed, we are looking over the horizon in this panel. So I want to make this really strong point, which is from building new apps against the same data, right? So you need to solve for access, right? Some intelligent replication. The future of ML is a big one. So training ML models takes a lot of horsepower, and sometimes very specialized horsepower. So for training ML models, hybrid bursting workloads are becoming quite common. So for that, you may create secured access back to your data store. You may move some of the training data. You typically aren't going to train your models on 100% of the available data because you have overfitting issues or potentially underfitting issues. But that bursting is super important, right? Training an ML model could take 20 hours, right? And then you want to get it into production, and then you're just going to be running it at line rate. So you don't worry about it at that point. It's going to run wherever you have the rest of the application as a microservice. You might think of it as an AI microservice, but that training phase is distinct, and that's where you get really good cloud economics. So you can say, we're going to get 20,000 GPUs on this thing, and we're going to cut the training time down to 10 hours. That's a big improvement, right? A 2x improvement by making that change. That's the economic driver to say I need a little bit more federated access to my data, whether or not it's portable. So that's something for the audience, I think, to consider as you're planning your strategy, as you're thinking what's 3 years, 5 years down the road. You need to have a really high level of AI competence, and your AI competence is going to be enabled by your knowledge of physics and economics. And if you have those things under control, you're going to be fine.
Very interesting. Very interesting. Yeah, definitely something new that I learned and something to keep an eye on. Let's see. So we're almost at time, folks. So I want to start in a closing part of the session by asking all of the panelists, if you can mention one trend that you're probably most excited about for 2021 and future. Let's see, starting with Suresh.
Wow, one trend, it's very hard to pick one from, but what comes after 5G rollout is going to be a whole ecosystem of new app services that are going to come out at the edge and new ways of implementations. Say, for example, if you have a hailing app, so to say, or a food ordering app, so to say, you don't need to do a full round trip, back to the public cloud. You could just, have it everything at the edge, because you're just going to order food somewhere within a mile or two radius. But still, all of these apps will have a very common pattern, which is globally local, locally global. But all the interactions will be at the edge, but the behavior patterns and the data that we collect and the analytics that we can run, all of that will be at a global scale. So I'm really excited of what comes after 5G.
Interesting. Yeah, especially that edge pattern. Very interesting, Suresh. Madhuri?
Yeah, sure. I'm most excited about the cloud vendors actually embracing the nodeless model and actually prioritizing container as a service options like Fargate and ACI. The feature completeness of these units is like moving at a really high speed, so that'll actually going to be super beneficial to the end user, so they don't have to worry about babysitting their cloud compute for their Kubernetes clusters and focus on building their apps and forget about being vendor logged into a single cloud provider. So that's actually helping the nodeless ecosystem in general and the end user in particular in increasing their adoption of Kubernetes as a commodity platform on public cloud.
Yeah, well said. Very interesting. Vaibhav?
So for me, it's going to be a shift left. It is really about when you think about all these typical day two concerns, data protection, security, and all of this becoming part of like the application development cycle itself, being very much part of day one, day zero, infrastructure as code. This is for me, I've been working in infrastructure for a long time, and it's what's changing what products look like, what we all build every day. So it's the most exciting trend.
Got it. And Sam?
I'm excited about 2021 being the year of ethics on data. So much of the data we're swimming in, we look at as technologists and we just say, here are all the things we can do. But most of the people I've been talking with about, the future of data on Kubernetes are talking about our ability to take policy and how do we govern the data and how do we enforce that computationally. And that to me is very exciting, because this intersection of computer science and the liberal arts, right, to quote the great late Steve Jobs, is what we now have to think about how we govern society. So it's becoming a much more common conversation. How do we bring ethics into how we think about and act on data, and how do we start to enforce those kinds of concerns? I think 2021 will be an amazing year for that.
Interesting. Very interesting. Folks, I want to thank you all. I know we're at the top of the hour. There's a ton of really great information that we learned and shared as part of this session. So thank you for joining. And for the listeners, have a great rest of your day and enjoy the conference.
Thank you.
Thanks, Madhura.